Welcome to our super quick review on how to name molecular compounds. Remember that molecular compounds are formed when electrons are shared between non-metal elements. Our objectives today, we're going to review how compounds form and summarize the rules for naming covalently bonded molecular compounds. The bonds are called covalent, the compounds are called molecular. So remember that compounds are two or more elements that are chemically combined in fixed proportions. Chemically combined, so we're not talking about mixtures here. And this idea of fixed proportions means that the ratios of the atoms of the elements stay the same. H2O is water. It'll always be in a ratio of 2 hydrogens to invisible 1 oxygen. If you had a different proportion of hydrogens and oxygens, for example, H2O2, this would be a different compound because we have changed that proportion. Fixed means it stays the same. Water is always H2O. If you have H2O2, you have a different compound. This is hydrogen peroxide. So why even do elements combine? We have this magical thing called the octet rule. We like to say that 8 is great. Basically, what's happening is that atoms are very stable if their valence energy levels are full. Remember that valence energy level is the outermost energy level. Basically, atoms want to be like the noble gases because they have full valence energy levels. Interestingly, even though 8 is great, 2 can also be cool because that very first energy level can only hold 2 electrons. We only have space for 2 because there's only one s orbital in that first energy level. So we're going to fill up with 2 in the first energy level. After that, 8 is great. We're going to count all of the s and p electrons. We're not going to worry about the d's or the f's. So s and p, we can fit 2 electrons in s and 6 in p, and that gives us a total of 8 electrons. Let's do a quick little review of ionic bonding. Remember that electrons are transferred. We're going to transfer those electrons, usually from a metal to a non-metal. We're going to get a net charge of 0. We're going to balance all the positives and all the negatives to get to 0. If we have 2 elements, we're going to call these binary compounds. The first element that we name will be the cation, which is the metal. The second one will be the anion, which will be that negatively charged non-metal. We're going to change the end of that non-metal's name to "ide." If I'm looking at the compound in the graphic here, we'll keep that name sodium. That's the cation because it's positively charged. Fluoride is the negative ion. We're going to end it in fluoride. So sodium fluoride would be the name of this compound. If we have more than 2 elements, now we're going to use our list of polyatomic ions. Remember that you want to keep the whole entire formula of the polyatomic ion in the formula of the compound. We're going to lose the charge, though. Do not put the charge in the final compound formula. And of course, if you have a transition metal, we don't know the oxidation states of those because they can change. We're going to add Roman numerals to tell us the charge of that transition metal cation. Putting away our ionic review and focusing now on molecular compounds, and this will be the focus of the rest of today's lecture. Molecular compounds don't transfer electrons, they share them instead, and those electrons are going to be shared between non-metals, and sometimes metalloids can act like non-metals in these molecular compounds. This graphic is super nice, showing us how we have this electron of hydrogen and this electron of oxygen, and it's being shared. So if you think of these bonds, atoms, as kind of like Venn diagrams, we can put hydrogen's electrons here and get rid of some of those scribbles so you can see them. So hydrogen now has 1, 2 electrons, but if I write a different Venn diagram circle around the oxygen, notice that oxygen has 1, 2, 3, 4, 5, 6, 7, 8. 8 is great. And so we can share these electrons and kind of look at these orbitals in terms of Venn diagrams and see how those electrons could overlap so that everybody can get that full valence energy level. Just a quick review of metals, nonmetals, and metalloids. Metalloids are here in that step stair spot. Metals are to the left. Nonmetals are in that top right corner. Good? Good. So all the magical memes reminding you the dangers of dihydrogen monoxide. Starbucks uses thermally agitated dihydrogen monoxide in all its beverages. It is known to cause severe burns on contact with skin. Also, dihydrogen monoxide has been found in cancer cells. Also, dihydrogen monoxide can be found in toilet bowl cleaner. Why would you consume a chemical used to clean toilets? Dihydrogen monoxide is an acid with a pH level of 7. That's a higher pH level than any other acid. And also, if dihydrogen monoxide can rust these pipes, just imagine what it's doing to your insides. And of course, these are super funny because dihydrogen monoxide is water. Dihydrogen, 2 hydrogens, monoxide, mono is our prefix for 1 oxygen. This is just water. But all those memes are super true about water. Kind of fabulous, right? So our rules for naming binary molecular compounds. Binary means 2, my friends. We only have 2 elements, 2 nonmetal elements only in these compounds. We're going to use prefixes, except we're not going to use a prefix if there's only one of the first element in the compound. The second element will always get a prefix, and we're going to change the end to "ide," and those are all the rules. So I'm looking at capital N, capital O, that's nitrogen and oxygen. Since there's only one nitrogen and it's the first guy, it does not need a prefix, but the second element will always get a prefix. So even though there's only one oxygen, we are going to call it monoxide for 1 oxygen. Notice that we changed the N to "ide." Here I have nitrogen and oxygen. Again, kind of a cool thing about molecular compounds, they can share their electrons in different ways. And so instead of just balancing the charges one way, we have lots of different ways to share, which is why we need to use those prefixes. So here I still just have 1 nitrogen, no prefix needed since nitrogen is the first element in this binary compound. I have 2 oxygens, so I'm going to call it dioxide instead of monoxide. And then here I have more than 1 nitrogen. So even though it's first, I do need to add a prefix because this is not 1, it's 2. So I have di for 2, dinitrogen, tetroxide because there's 4 oxygens, tetroxide. Good. So we're going to use these prefixes. These are our prefixes. If you don't have them written down somewhere, you should write them down somewhere. Most of them are pretty easy to remember because they sound a lot like the ones that we use in math. The one big difference is maybe for tetra. In math, we tend to use quad instead of tetra, but in chemistry, tetra is 4. So keep that in mind. If you need to write these down, pause the video. Otherwise, remember that 1 is mono, and then 2 is di, and then tri, tetra, penta, hexa, hepta, octa, nona, deca. Say it to yourself. Good. And get these written down if you need to. All right, so let's practice a little bit. If I have H2O, we did this one a couple slides ago, but we're going to practice one more time. I have 2 hydrogens. My prefix for 2 is di. I'm going to call it dihydrogen. I do not change the name of the first guy. The second guy, we're going to always add a prefix. There's only 1 oxygen, so we're going to use the prefix mono. I'm going to call it monoxide. Change the end of the second name to "ide." Next one, only 1 carbon, doesn't need a prefix since it's the first one, so it's going to be just carbon. We don't change the end of the first element's name. Oxygen, there's only 1, but since it's second, we do need a prefix. It's going to be monoxide, mon for 1, ide at the end because it's the second element. Here I have carbon and I have 2 oxygens. I'm still going to leave carbon, carbon, because there's only 1 and it's the first element. We don't do anything with its name. We're going to change the prefix for this guy to di since there's 2 oxygens. So di, ox, and we're going to change the end of oxygen to ide. So carbon dioxide. Nitrogen, there's only 1. I don't need to change the name. Nitrogen. 3, our prefix for 3 is tri, and iodine is iodide. We're going to change the end to ide. 2 more. Cl2O. I have 2 chlorine, so I do need to use a prefix di. Chlorine. I'm not going to change the end of the first element, but this second guy always needs a prefix. There's only 1, so I'm going to use mono. Oxide, we do change the end of the second element's name to ide. 1 more. I've got 4. 4 is tetra. Phosphorus. I'm not going to change the end of phosphorus because it's the first element. The second guy, though, I have the prefix deca. Since it's oxygen, I'm actually going to use decoxide. Notice that we changed the end of the oxygen's name to ide. And even though there's deca, it's oxygen, so we kind of smash those vowels together and just call it decoxide. All right, we're going to flip. We're going to go the other way. Selenium. Selenium is capital S, lowercase e. There's only one because there's no prefix. Tetra is 4. Fluoride is capital F, little 4, that subscript of 4, selenium tetrafluoride. Carbon, I only have one, so just big C and only one of them. Sulfide came from sulfur, and there's going to be 2 of them. Tetraphosphorus. Phosphorus, remember that tetra is 4 phosphorus is phosphori. I'm not sure what the plural of phosphorus is. Trisulfide, capital S for sulfur, because we get sulfide from sulfur, and then tri will be that 3. Dinitrogen, dichloride, nitrogen's coming first. I have 2 of them. Chlorine is next. I also have 2 of them. Notice that we did not change the end of nitrogen, but we do change the end of chlorine to chloride. Nitrogen, no prefix, means only one of them. Fluoride, now I have 3 of them. Trifluoride. Sulfur hexafluoride, sulfur, only 1. That's a big capital S. Fluoride, I have F, and then hexa is 6, my friends. And we did it. Objectives accomplished. We reviewed how compounds form. We can either transfer electrons, or in the case of our molecular compounds, we're going to share those electrons. And then we summarized the rules for naming covalently bonded molecular compounds. Prefixes. Use the prefixes unless there's only one of the first element. And that's it. Easy peasy. Good job today, my friends.